Okay, thank you. Okay, so I'll begin. Okay, so hello everyone. Hope everyone is having a good evening. My name is Jia Hao and I'm from Star Labs. So today I'll be sharing about some of the interesting things I've seen while working on code review, analyzing open source web apps, in particular the Chamilo web app. So we will mainly cover some basics for getting into web app source code review, and hopefully those that are new to it can learn something from this sharing. So a short introduction about myself. I graduated from NUS last year, and I'm currently working at Star Labs as a security researcher. So basically, personally, I started being quite active since my uni days, setting personal goals for myself and going for all the different kind of certifications and playing more CTFs. So some of the write-ups I have is actually on my GitHub or on my CTF team's GitHub. And on the side time, during my free time, I also do like some bug bounty hunting. Yeah, so part of what I do now daily is looking at code, reviewing them, looking for ODs, analyzing any those bug reports in the world that people disclose, as well as thinking of new research ideas. Okay, so let's get started. So this sharing will be mainly about my experience in reviewing the open source LMS known as Chamilo, and the entire process, the top process. So we'll first start by having a run through on what exactly is source code review and how we can go about doing so. Then once we think we've found a vulnerability, we will need to verify that it actually exists in the application and not just like unused code. Then finally, after knowing how this process works, I'll share with you guys some of the more interesting bugs that I found in this application. So what is source code review? Source code review actually usually refers to examining the given source code and trying to find any kind of security flaws. And we're usually interested in logic errors or any kind of dangerous coding practices. Okay, so why we do it is because perhaps we want to sharpen our code review skills, and at the same time, you could actually earn some CVE as a bonus. And more importantly, the main thing is to train yourself to be able to recognize vulnerabilities when you're given actual code. So in order to do the reviewing, you can actually use automatic tools or do it manually, but both methods are important because even if your automatic tools flag out all the different findings, you still have to manually verify it. So today's focus will be on the manual aspect. Okay, so Chamilo is a open source LMS, learning management system, written in PHP. This target is chosen because I want to practice on reviewing some application with a pretty sizable code base and getting comfortable with doing so. So if you look at the GitHub page, it's still in active development, and I think they're releasing a version 2 with a refactored code base. So we git clone the repo, and then so how do we even begin to find the bugs? Because the code base is so huge, right? There are literally thousands of lines to look at. So let's narrow it to a simple objective in mind. We want to find if there's a way for our user input to reach any kind of dangerous function and affect the intended behavior. Using this illustration as an example, even though it's PHP, I hope it's roughly understandable for those that don't know any PHP. So on the first line, we see that the user input, HTTP request parameter, is assigned into the PHP variable A. I'm not sure you can see my cursor, but okay, so this is obtained when incoming HTTP GET request, and there's a query string, this user input. And in this case, it's actually set to /10/uploads. So the program then runs this, then passes this value through function A, as indicated here, and then function B. And finally, in function B, we see that a system function is called. So in PHP, this system function actually runs OS commands. And we can roughly tell that in this case, they want to execute a list command on the chosen directory. So some of you might have already spotted the issue here, but for those that didn't, so what happens if the input actually contains other additional values? Okay, so if the input contains a semicolon followed by additional system commands, such as who am I, they will also get executed as well. Okay, so see how we trace our input from the controllable input and reaching the dangerous function. This is known as source to sink tracing. And this is the diagram to show the flow. Of course, we can also do it in the other way. The outcome is the same, except that we start from the sink and try to end at the source. So if you can reach from one end to the other, then it is probably a vulnerability that we can exploit. Moving forward, so there are many different types of sinks and sources available, depending on the language itself. But in general, the idea is the same. We want to, there are the source and then there's the sinks. So in PHP, the typical source that we see are usually this get, post, and request. Of course, they are not the only source in this case, just the common ones that you will encounter. We just saw how user input is passed in through the source in the previous slide. So for the post, the keyword post is the same as well, except it's in the request body. And for request, it is actually a combination of both the get and post parameters. As for the sinks, in this case, we'll just look at direct RCE. For PHP, it includes like system exec, shell exec, popen, and many others. There's a lot in PHP. Then in Node.js, assuming that the server is actually running Express, the query parameters are usually passed in using this syntax here. And the sinks are actually like eval, child process exec. And in Java, depends on the frameworks being used because there's a few types. In Spring, we can look for this request param annotation. And if the framework is actually using struts, then you just look for this get parameter param. So this is actually just a rough gauge, so you don't get too lost when you look at this. And for the sinks, is the usual runtime exec or process builder starts. If you can control either of these, usually you can achieve RCE. Okay, so since today's focus is on PHP, we'll just look at the PHP ones. Okay, so OWASP top 10, in case you don't know what is this, actually a list of the top 10 most common vulnerabilities as seen in the wild. And there's a list every 3 or 4 years. And the current one is actually the 2021 one, shown on the right. And the left is the old 2017 lineup. We'll just take a brief look at a few of them in the 2021 list since we do not have too much time. Okay, so the first one is the broken access control. So what this means is it typically refers to like if you are a normal user of an application and then there's certain features restricted to admins, for example, and as a user, you're actually able to access them, so it's not properly protected. And as such, it's considered a kind of broken access control. So one of the worst impact probably is if you can use this unrestricted feature and escalate your privilege into a higher role. So next is the injection, which combine the injection various categories in 2017, like all the cross-site scripting and injection and all that into this one single category. So it covers things like SQL injection, cross-site scripting, and code injection. So as such, the RCE example that we saw just now falls into injection category. So take note that there are many ways to achieve RCE, so don't have the false association that injection means RCE, because it's not always the case. So yeah, so let's just cover one more item, which is server-side request forgery, or SSRF for short. So SSRF refers to when attackers are able to force the web server to make a request that is not actually intended by the developers, because the application failed to validate the request, whether it is safe or not. And by being able to force the server to make requests, the attacker can actually force it to send arbitrary requests to internal servers and networks, which the attackers cannot reach directly. So the maximum impact, I guess, is if the application actually returns the internal response back to the attacker, then the attacker can really just interact directly with the internal resources. Okay, so the rest of the top 10, I hope you guys can take some time to read because it's a lot more use examples and elaboration. especially if you are trying to find web vulnerabilities, you should know what you are trying to look for in the first place. Okay, so let's look at finding what we want after downloading the code base. In this example, we'll use VS Code to search and help us find some interesting code. So in the VS Code, if you click on the search tab, you can actually fine-tune some settings. So first, the yellow ones actually is enabling reject search as well as case sensitivity. Usually you want to open this blue extended menu, is closed by default. Then after opening it, you'll see these two new input boxes, which actually lets you filter by file names or even directories that accept wildcards. Okay, so for some web requests, how do you find using the search? So example rejects would be like this. Of course, it's not the best. So what this reject does is you look for a dollar literal followed by any number of characters, followed by an equal sign for assignment, followed by any number of characters, and another dollar sign, and underscore, and either one of these words. In this case, for PHP, yeah. So you see in this screenshot on line 8, we see that the ID from the GET request, if it exists, is assigned into the ID variable in PHP. So what you do usually is you try to see if this ID variable is used in any kind of dangerous forms. Yeah. So what about sinks? Just now was source. So sinks, you can just look for the keywords. In PHP case, we'll use the words that we saw just now. And so the either any one of these keywords followed by an open bracket. And in this screenshot, you see that in this case, we have an exec, and it uses the string variable program. And if you trace backwards, it's actually from a for loop variable. And if you look further up, it's actually from a hard-coded list of arrays, so nothing there, unfortunately. So we can also look for other kind of things besides just RCE, then such as file read. In the case of PHP, we can actually, there are a lot. So this is just one of them, the file get contents function. This is interesting because this function lets you specify local files or even URLs. So if you can control the protocol, you can actually do a lot of things with it. And in this screenshot, we see that on line 43, the get parameter image, if it's set in the URL, it will be assigned into this URL contents PHP variable. And just ignore this. On 52, this variable is actually used directly inside the file get contents function. So if all goes well, we should be able to just control what goes inside file get contents just by specifying the URL. Okay, let's just keep this piece of code in mind as it will appear again later. Okay, then of course there's the classic XSS client-side scripts, client-side and sinks. So PHP typically uses the echo keyword to print out the HTTP responses to be displayed in the response. And using echo key, this kind of rejects, we can actually just search for simple echo keyword followed by any characters and then some concatenation using a variable. Okay, so on line 46, we see that it actually echoes whatever is inside the title variable. And if we can control this variable, we can actually just print out an XSS or something. Then, so of course, the rejects that are shown is not perfect. There's definitely improvement to be done. It's just some quick and simple rejects to just get a grasp of the code base. And there's tools like this to help you adjust your rejects to refine your searches. So besides using VS Code to search, we can also rely on the trusty grep command tool. Yeah, so these two searches have pretty good speed, and some of the basic arguments we would usually use are as shown in this table. It is quite self-explanatory besides the L and the N. So L actually lists the file names of the matches instead of displaying all the different matches. Then the N is actually a good one. it shows the line number of the matches itself. So you can easily find the line that you want after you open the file. Okay, so here's an example of searching for system recursively, starting from the current directory, as indicated here. So we see that there's a lot of results, and yeah, we should actually refine this because we're matching other stuff like file system. Yeah. Okay, so it's just now this also with the N flag, you can actually see the line numbers, and for the L flag, you see that instead we just see the different files as the results. Okay, so some additional arguments that can further refine the results. And what's important here, okay, we'll actually go through. So using the E flag, you can actually use regex in your search, and this will be the same as what we saw just now in the VS Code search. Is the screen laggy? No. Oh, okay, looks fine. Okay, so if we search for exec, we see that we get a lot of different matches, including like JavaScript files. We don't want this because we're not interested in this. So we can actually use the include flag to specify that we are only interested in PHP files. And we see that we are getting results from this test directory, which presumably is from all the unit test files. Also, these are not really that interesting. So let's just exclude the directory entirely by using this exclude directory flag and specifying the test. So now we are left with all the ones that we are possibly interested in. Okay, so assuming that we have found a few potential bugs, and how do we even verify that if they're exploitable or not? In order to do so, we will have to set up local instance for testing. Please do not test on public instances without any permission to test. And yeah, you can, to do this, you can actually create your own Docker images, or better yet, some code bases actually maintain their own up-to-date Docker image for letting people have an easy time to deploy and test out their apps. Of course, if you are lazy to deal with Docker, you can just install in a VM, but that is not recommended at all. In the next few slides, we'll just quickly run through how to set up a local Chamilo instance, test out some bugs. You don't have to do it now because we'll just look at code snippets later. Okay, so we have to obtain the source code. Let me just paste this into the chat so that you all can check it out later. Okay. So alternatively, I also prepared a Docker setup for this code base. This is the easy mode one. So if you're unfamiliar with Docker, you can just copy this file and run it. I will also copy this into the chat box. Yeah, I think the formatting is a bit screwed, but okay. So after you run it, be warned that it may take longer depending on your internet speed, and the container size is a few GB. So go through the installation steps to set it up. Just click Mix and Auto Default until you see this page. This is the one you should take note of because it is to do with the database connection. So a lot of applications require a connection to a database during setup, and this is no exception. So in this case, we'll just set the host to be MariaDB and default port, and the rest just the single word Chamilo. Yeah, so this actually defines the Docker compose file. So just now the one I pasted, you can just change it as you need. So after all the steps, they're actually just fast forward for you guys. Although it's specific to Chamilo, the general idea is the same. So you want to find an application, then if possible, you Dockerize it, and then you can just play with it in the local setup. So because having a local setup, we can actually try to be a user and look through the lens of the user. The more we understand the application functionality, the more we'll have the idea to think of where it could go wrong and look for flaws. So as you hone your skills, you'll just develop a kind of sense for dangerous codes. Okay, so finally, let's just look at a few interesting bugs that I found while digging an application. So for each bug, I will show the relevant snippet and see if you all can find the vulnerability. If not, I will just go through it all. Okay, so the first one is SQL injection. So in the application itself, this one is an authenticator bug, so you need a valid user account to exploit. Okay, so let's start with something straightforward. So examine this snippet as shown. To make it clearer, I've already removed a lot of redundant code from the original code itself. So maybe we can take like 15 seconds to just see if you can spot the vulnerability. Once you found it, then think about how you can exploit it. Okay, so shouldn't take too long if you know this classic one. So on the line label 1, we have our source. So a GET request with this parameter set will get assigned into this block ID PHP variable. Then we'll just see two more different variables being instantiated, but we just ignore this. Then we see the query itself, and we see that the variables that we actually control, the block ID, is used in a string concatenation manner as part of the query. So the injection actually happens here because the developers did not have any kind of code to sanitize your user control input. And to exploit this, you see that in this case, the query actually just selects a count. So it expects an integer. And so we cannot just like union select other kind of tables and then expect the application to just show all the data on the response. So this actually considered a blind injection. To exfiltrate meaningful data, we actually have to structure our query such a way that we can infer from the output instead. Okay, so this can be done by structuring our injection query like this. We want to have a true or false query, as well as a true case, and what happens during a false case. So of course, the best scenario is when the outcome of the true or false is shown in the response itself. Sometimes this response can either be like different kind of numbers, in this case, numbers being returned, or if one of the case throwing an error. So if there's no error, we can actually try to induce it. And as a last resort, we can always make the database sleep for responding. So it's the last resort because it actually takes a while to exfiltrate significant, like relevant data or useful information. Okay, so you see that we're using this case when this syntax is for MySQL. So other SQL might have different syntaxes. Okay, so let's fill in the templates. So our our query will be if 1 equals 1, then if it's true, then we'll return 1. Otherwise, we'll just return 0, which will be selected in the union. Okay, so in this case, for this application doesn't show the outcome of the number itself. So we have to force it to throw an error. So let's make it throw an error in the else case. Okay, so we do this by selecting a column of strings, which will actually throw an error. There's many ways that you can this is just one example of throwing an error. So you see when it's a true query, you just get 1. If it's false, you get some kind of error. Okay, so next, we want to change our query. This 1 equals 1. So let's try to find the current database user. So we want to have run the user function. And since we can only ask true or false, unless we can just guess the whole string, it's not realistic. So we have to do it character by character. So we'll use the substring function on top of this, and we'll take the first character, and we just take 1 character. We'll just check if the first character is equals to the lowercase c. So by this logic, if it's equals to c, we should get 1. Otherwise, we should get an error. Yeah. Okay. So throwing everything together, the injector query will look like this on the application end. And you see that when the first character of the user is equals to lowercase c, we should get 1. Otherwise, we should see some form of error. And of course, your injection query should comment on the rest of the original query. Okay, so to actually exploit this, you should create your own custom script because if not, you have to manually guess character by character and iterate through all the alphabets and numbers. So either you write a script or you use SQL map to exploit this. Okay, so this is the output when we get a false query. The application notifies that an error has occurred. So this is likely due to our induced error in the false case. Then for the true query, unfortunately, I think the applications has some issues with handling with what you wanted to display. But nonetheless, with this, we are able to distinguish between true and false output, which is all that matters, honestly. Okay, so actually, yeah. Okay, let's see this SQL map in action. So you just run and then it's automated. Nothing much to say. Yeah, okay. Let's go next. Okay, so let's look at a second vulnerability, another SQL injection. So once again, examine this snippet again, and the redundant code has been removed. Let's take another 20 seconds to see if you can spot the vulnerability this time around. Okay, so on the line label 1, you see that the GET request, if you have a file parameter set, the string will actually get assigned to the .url PHP variable. And we see some kind of sketchy string replacement going on here, but the only important one is this one, where your spaces are actually replaced with the plus symbol. So that means we can't use spaces in our injection query. Then we see this, the actual query itself. And once again, we see that the .url is concatenated into the query directly. So unfortunately, this injection also has some issues like the previous one where the true or false thing shows some weird PHP warnings. So to exfiltrate our data, we have to structure it similarly. So we just skip straight away to this step. So notice that there's 2 additional columns we have to select this time because in the original query, they actually selected 3 columns. So we have to match it. If not, your injected union query will not actually run. So the green part, the thing we're trying to exfiltrate is the same. So we check if the first character is equals to lowercase c. Okay, so the rest is the same. Okay, yeah, so that was spoiler. So if you play a lot of CTF, it should be easy for you. So comment blocks are actually treated as spaces. So you can just substitute all the spaces that you want with comment, and then this will just run as per usual. Okay, yeah, this is an example. Yeah, so once again, if you want to extract meaningful data, you need to either write a script or use SQL map. In SQL map, you can actually use this temper, which can modify the payload that you are sending. In this case, we are using this space to comment, which, as the name says, it will just replace all the spaces with comments. And the exploitation is the same. Wait until it finds it. Yeah, you found it, and then you just exploit it, getting the current user because that's what I indicated. Yeah, okay. Okay, so let's look at the third bug. This time is an interesting one. It's a food gun example. So it's like when developers unknowingly implemented too many features or those features that have side effects that they are not aware of. And sometimes this can be due to different libraries conflicting with each other. So more does not necessarily mean better, as we will shortly see. Okay, so the first So in this case, it's a sanitization feature in the code base. So there's two of them. The first one is actually the one shown here. It happens when you are trying to upload a file and onto some document section in the website itself. Okay, so this filter looks pretty okay for getting the job done. And so we cannot just upload any PHP extension files. Yeah, so if you try to do so, you actually see that you'll get renamed to .phps. And if you want to download the file itself, it'll also be in PHPS. Okay, so the second sanitization feature is actually a site-wide function. So this is a different one from the previous one. It was for documents uploading. So this second one is hidden behind an administrator panel, and it checks whenever a file is uploaded to the server, be it from the documents section or any kind of file uploads. And in the case of this application, this sanitization takes place just before the file is actually returned to the server itself. So after the first sanitization we saw just now, where it renamed PHP to PHPS. And in this form, a cross-site request for jury vulnerability exists. So the submission does not actually include any kind of anti-CSRF measures. And furthermore, the session cookie does not make use of the same site attribute. So what this actually means is that as an attacker, we can host a web page that will just submit a form containing all the different values that we want. And once an authenticated administrator actually visits our site, they will get forced to submit this request. It's as if we are controlling the form itself, but we need the administrator to first be logged in on the website and second to click on the link. So in this case, let's just assume that we have control over the admin form because CSRF is possible. So this is the CSRF in action. So assume that the administrator log in. And yeah, once they log in, we see that the settings, this is the default settings after you install the application. So you replace it with dangerous. And once the admin actually visits our page, we'll force them to submit a form and change it to all the different values we want. And we see that the update is successful, means and we see that we changed the blacklist settings. We blacklisted the PHPS extension, and we will actually replace it with PHP. Okay. So since we can change the second sanitization feature, we can try to use it to defeat the first sanitization feature. So this after the CSRF happens, we change the mode to change PHPS to PHP. And then now when you try to upload a PHP file, look at what happens. Yeah, so just ignore this, whatever it says PHP, but actually, if you try to download the file, you see that it's in PHP. So I can confirm that we have just used the admin sanitization feature to bypass the file upload sanitization feature. Okay, so after we have uploaded our PHP file, we assume that it's a web shell. And if you try to access it directly, you'll get a 403 error. This could be due to an existing htaccess file trying to prevent you from requesting it. So let's take a look at the htaccess at the root directory. And the relevant one is this. So we see that our request is actually blocked by this. That's why it's returning a 403. So this regex actually has a mistake in the sense that if your URL ends with a slash, then the match no longer hits because of this dollar symbol here, which denotes the end of a match. Yeah, okay. So if you input it into just now the regex checker website, you see that our original request URL is actually matching the regex. That's why it's failing. And if you write a slash at the end, as indicated here, we see that we can actually bypass this check and access our web shell directly. Okay, so yeah, so to recap, we just use the features of the application to defeat its own other security features for an epic outcome. And starting with the CSRF attack, we can actually change the sanitization settings on the admin page. Then we uploaded the PHP web shell, and due to a misconfiguration on the htaccess style, we can actually access the web shell directly and achieve RCE. Okay, so let's look at last bug, which is actually 2 bugs chained together into one to achieve RCE as well. This time around, we don't need to fish the administrator to achieve it, which makes it a lot higher impact. Okay, so the first one is actually the insecure file upload. We will be using the same upload function that we have been seeing. So as you can see in these illustrations, applications that have file uploads need to account for all sorts of dangerous scenarios whenever a user uploads a file, because the worst thing that can happen is probably a user uploading a web shell to run system commands on the web server itself, or uploading like malware. Fortunately, in this application, they have taken some precautions when it comes to directly uploading PHP file and running it, as we have seen just now. So it's not allowed with the checks we have. Just ignore the htaccess thing, but we'll look at how, even though they have the renaming from PHP to PHPS, we can still achieve RCE by uploading a PHP file. So instead of that, we can try to upload a FAR file. So a FAR file is a zip archive file which contains PHP file. The spelling is PHAR. So why are we uploading a FAR file? This is because we can if we can direct a deserialization sync to our uploaded FAR file, we can actually, there's a chance to achieve RCE depending on the code available in the code base. Okay. So the exploitation itself requires gadget chains, which is a term used for chaining existing code in the code base to create a path to a desired goal, such as RCE or file write. Okay, so today we won't be focusing on how this serialization works, because there's a lot of content to cover. Basically, if the code has known vulnerable libraries, we can actually use a tool to generate a FAR file for us. The tool of this choice is PHP GGC, which will actually create a malicious FAR file for us. And we just need to see if the code base is using any of these vulnerable dependencies shown in the first column. And then we'll look at the third column for what kind of effects we want to achieve. So we can look for RCE first. So we can find the dependencies that the code base is using by looking at the composer JSON file. There's a lot of options in this code base, but yeah, we'll be using the monologue library. There's a lot of chains we can use. Okay, so let's create a FAR. You may have to change some PHP settings if you try to generate this FAR file. If you see an error like this, you have to actually make some changes to your PHP ini file, which can be obtained by running the PHP info command and grepping for PHP ini. Then you want to open this loaded configuration file, and then look for this line and change the PHP, the FAR.read only to off, and remember to uncomment the line. Okay, finally create the FAR file itself. We'll be using the monologue RCE chain. So the payload will be to run the system PHP function, and we'll execute a reverse shell back to our machine. -p is for FAR, and O is the out file. So we'll call it rce.jpg. This so the file extension of the FAR file itself doesn't actually matter. Okay. So we upload this FAR file after generating it. Okay, it looks promising. So we can confirm by dropping into the Docker container and verifying the checksums. And in this case, we can confirm that the FAR file was uploaded without any issues. So now, if we can deserialize this file, we can achieve RCE. Okay, so that's the first bug, the insecure upload. So you can upload a FAR file. And let's look at the second bug. So this snippet that was shown near the beginning, I want you guys to take a look again, maybe 20 seconds. The sync is highlighted. So think about how you can exploit this to cause a lot of damage. Ignore this remove XSS because it only just remove angle brackets. Yeah, okay, so I think the time is actually running short, so I'll just move first. If you thought of using a file protocol to link local files, that's a good start. However, if as you can see the contents where the file is read, the MIME type is actually checked, and if it's not an image file, your execution dies here. And yeah, if you thought about using HTTP protocol to ping internal servers, it's also considered SSRF, but it'll be a blind one because once again, the response won't be a file type, image type. So you'll just die here again. Okay, so the most impact we can cause here is actually to make use of the FAR protocol. This actually lets you deserialize a FAR archive on the server itself. So the file must be on the server, not a remote file. Okay, so we found our FAR deserialization sync. We can now chain it with just now the file upload to achieve RCE. Okay, so the exploit URL will just look like this. We have to know where the uploaded file is at. Then using the FAR protocol, we can deserialize it. So let's replace it. We just assume the default installation is at the web root. And the course code depends on the course itself, but you can see it's in the URL, it's not hidden information. And uploaded file is whatever you call your file. Okay, so if all goes well, we should achieve RCE and get our reverse shell. And so we first start our listening shell. Yeah, we have to visit this page to store some session variable, but that's all you need to do. Just refresh. Okay, so we'll just trigger the deserialization and okay, see that reverse shell has been sent, which means that RCE was achieved. Okay, cool. Okay, so unfortunately, FAR refers to deserialize is in the file get content sync is no longer possible on PHP 8 onwards. So like all the different kind of file exist, file get contents, you cannot use FAR protocol anymore. Okay, so the last section will just be some concluding tips. Okay, so first of all is to never trust the comments and the naming conventions of the code. For example, in Chamilo code base just now, I mentioned about ignoring the remove XSS function because it only strips the anchor brackets. So because that's what it does, other kind of XSS can definitely slip through. So look at this code snippet, which is from the index page. User controlled first page actually goes into this echo sync. And even though there's this remove XSS, and it doesn't really stop the XSS because we are already in the script tag. So to exploit it, we just need to close the single quote and then just append additional JavaScript lines. Then terminate with comments. Okay, so yeah, so you can see in action. Okay, yeah, not that interesting seeing that we saw RCE already. Okay, so what this means, what this teaches us is that we shouldn't blindly trust whatever we see in the code base, even if it's something discouraging like remove XSS, because in this case, the developers themselves already got tricked by their own function naming and gave them a false sense of security. Always take a look at how the sanitization is defined, especially if it's written by the developers themselves. Because if it's some kind of sketchy looking code, you should spend some time and see if you can find a bypass. Okay, I think I'll skip this section due to lack of time, unfortunately. Okay, so finally, if you are trying to find some starting ground when you're looking at a new application. Consider looking at their past vulnerabilities, analyze what are the issues they have and how they fix it. See if you can find any bypass for the features itself. And if there's a repeating trend, you can actually try to look for the repeating bugs itself as well. Okay, so yeah, that will be all for today. Thank you for your attention, and I hope you guys managed to learn something from this sharing.